Okay, class. In this video, I would like to use one exercise from your textbook to comment a little bit about the application of the Morgan's law. Okay, so we are looking here at exercise number 51A. Yeah, number 51A. Let me just here 51A. Okay, on page 95. So I'm talking about this one. So we have this representation of two sets. In these two sets, we have three regions, 1, 2, and 3. The label of the regions in numbers is very similar to the one that we have for the three sets, with the difference that the one that corresponds to the complement, instead of being 8, is going to be now 4, because we have only 4 regions. Okay, that's what we have here. So they say, try to represent, I'm going to do this one, which is, they want us to identify a intersection B complement. Well, you can make this exercise by either using the Venn diagram directly. Okay, so they say here, for instance, okay, let me look at the intersection of A and B, which is region 2, is this one here. It's region 2. And the complement. What is the complement? The complement is all what is in the universe that is now in the region 2, which is 1 and 3, which is 1 union region 3, but also the complement in respect to the universe set union region 4. So you can use the Venn diagram representation to get the answer very easily. Okay, another option is, probably I should use here another notation, right? So I should use here something like, I don't know, oops, and here, what I'm doing? I'm sorry, guys. Let me just erase here. I'm sorry for this interruption here. So, option I, and another one, as you learned in a previous section in your lecture, in lecture 2.4, you know that you can use the Morgan's law to compute the complement of this intersection, right? Basically, you can distribute the complement with each one of these. So it's like to apply the distribution property, right? It's to distribute the complement operation with each one of the set, to apply the complement to this one, and to apply the complement to this one. A complement and B complement, and then the union is gonna be changed, the intersection is gonna be changed by union. So by using the Morgan's law, we obtain this. This is the Morgan laws. Okay? So the complement of the intersection is the union of the complement. So let's take a look of the union of the complement. What is a complement? A complement is all, and let me erase this for the moment. Oh my goodness. Let me just use this red to complement here, to to make this, redraw this one here, and then I'm gonna use the black one to write down again region number 2. Okay, so now let's go, I'm gonna use blue color. What is A complement? A complement is, well, all of this is A. A complement is all what is known in A. All what is known in A is this portion of B, which is region 3, together with region 4, right? Together with region 4. Region 4. Union B complement. What is B complement? Well, B complement is all what is known in B, which is region 1, together with all this part of the universe set, which is 4. So the union of this is what? Is, well, region 3, union with region 1, union with region 4. So it's basically this one and this one that are the same. It's the same solution. So you can go directly with the Venn diagram representation and identify the complement of the intersection, or you can apply the Morgan's law to get exactly the same solution as this one. Okay, so this and this are the same. So that is a comment that I want to make. This is something that you guys want to have in mind when you are dealing with exercise that involves the complement of the intersection or the complement of the union. So you can apply the Morgan law. Remember the Morgan law, right? Is the complement of the intersection, remember that, is exactly what we use here. So we distribute the complement operation with each one of the sets. That's the way to remember this. And if you have here intersection, then now you're going to have union. So if you have the complement of the union, so, well, you distribute the complement operation with each one of them is A complement and B complement. But now, if you have here union, then this is going to change to intersection. So the complement of the union is the intersection of the complements. And remember, this is the way to remember the Morgan's law. Okay? So that is the way. So you may have exercise. Let me show you in here. So let me see in here. I remember that I saw a couple of exercise that have to do. Yes, for instance, from your homework. Okay, from your homework, you have 1, 2, 3 regions that is coming from 2 sets, and then the region number 4 that is part of the complement in the universal set. So they say, okay, what is the intersection? What is the complement of each one of these? Well, you can apply again the Morgan's law and obtain whatever you want here. That is an application that you can use in this type of exercise by using the Morgan's law. Okay, so let me see if we have here another one. No, I don't see any other one. But this is one comment that I want to make for this particular exercise, this one here, that have to do with the Venn diagram representation of two sets and to use the Morgan's law as an application for solving or answering the questions that you may have over here. Okay, well, thank you.